What will happen to Earth in the next 5 billion years? First, let's start with 10,000 years in the future. At this time, the entire East Antarctic ice sheet will melt. Sea levels would rise to 3 to 4 meters. One of the potential long-term effects of global warming. This is separate from the shorter-term threat to the West Antarctic ice sheet. 10,000 to 100,000 years in the future, and Betelgeuse and Antares are expected to go supernova. For a few months, the explosion should be easily visible on Earth in the daylight. In 36,000 years, Ross 128b will pass within 3.02 light-years away from Earth, making this star the closest one to Earth. 50,000 years in the future, and the interglacial period will end, sending the Earth back into a glacial period of the current ice age, despite the effects of global warming. However, according to a more recent study, climate change, if left unchecked, may delay this expected period by as much as 50,000 years, maybe even skipping it entirely. Another interesting thing that will happen in 50,000 years is that a day on Earth will be longer than it is now by 1 second. Fast-forwarding 500,000 years in the future, Earth will likely have been hit by an asteroid that is roughly 1 kilometer in diameter, assuming it is not averted. In 3 million years, a day on Earth will be a minute longer than it is today. It used to be predicted that in 40 million years, both Phobos and Deimos will collide into Mars. However, it seems now that Deimos will move away from Mars very slowly, so only Phobos will suffer the fate of colliding into Mars. The Canadian Rockies will wear away to a plain in 50 million years, 100 million years in the future, and Earth will have likely been hit by an asteroid comparable to the size of the asteroid that killed the dinosaurs 66 million years ago. After 180 million years, the Earth's day will increase by 1 hour. All the continents may fuse into another supercontinent between 250 and 350 million years. This will likely result in a glacial period, lowering sea levels and increasing oxygen levels, further lowering global warming temperatures. Then, after 400 to 500 million years from now, it will have rifted apart. In 600 million years, tidal acceleration will have moved the Moon far enough apart from Earth that total solar eclipses will no longer be possible. Extremely interestingly, in 800 to 900 million years, the carbon dioxide in our atmosphere will fall to the point at which photosynthesis is no longer possible. This will be a problem because without plant life to recycle oxygen in the atmosphere, free oxygen and the ozone layer will disappear from the atmosphere, allowing for intense UV light to reach the surface. Unfortunately for the future animals on our planet, at most, they could survive 3 to 100 million years after plant life dies out. Some animals may be able to survive in the oceans for a while, but after some time, they too will become extinct. The only life left on Earth will be single-cellular organisms, nothing else. 1.1 billion years in the future is when the Sun's luminosity will have decreased by 10%, which makes the temperatures on Earth increase. The average temperature on Earth will be 116 degrees Fahrenheit at the time. After 2.5 billion years, the Sun will have reached a maximum surface temperature of 10,020 degrees Fahrenheit. From that point on, as the Sun becomes larger, the temperatures will cool down. 300 million years after that happens, Earth's average surface temperature will become 296 degrees Fahrenheit. Yes, the process of life becoming annihilated will begin 800 to 900 million years in the future, but it will continue for a long time. High estimates for when all remaining life on Earth becomes extinct, except single-cellular organisms, is about 2.8 billion years from now. 3 to 4 billion years in the future are chaotic years for our home planet. The Earth's core freezes if the inner core continues to grow in size, based on its current growth rate. Without its liquid outer core, the Earth's magnetosphere will shut down, and solar wind will slowly deplete the atmosphere. There is roughly a 1 in 100,000 chance that at this point Earth will be ejected into interstellar space by a stellar encounter, and a 1 in 300 billion chance that it will be both ejected into space and captured by another star. In 3.5 to 4.5 billion years, the Sun's luminosity will have increased by 35 to 40%, causing all water that is present in lakes and oceans to evaporate, if that hadn't already happened because of the extremely high temperatures present on Earth. Speaking of that, the Earth's average temperature will be 2,060 degrees Fahrenheit, which is hot enough to melt some surface rocks. The Milky Way will collide with our neighboring galaxy Andromeda in 4.5 billion years in the future. After 500 million years from this time, the galaxies will have fully merged. This will form a galaxy dubbed Milkomeda. About 5 billion years from now, the Sun will become a red giant star and will consume Mercury, most likely Venus, and maybe even Earth. However, after a while after that, Earth and the Moon will likely be destroyed by the falling Sun. During this period, it is possible that Saturn's biggest moon Titan might have surface temperatures that may be suitable for life, because of the new distance from the Sun for this moon. Shortly after that, in space terms, the Sun will turn into a white dwarf with about 54.5% of its current mass. This is what will happen in the next 5 billion years. Please subscribe if you would like to learn more about space phenomena like this.